All right, we're going to talk about one-step equations. That just means hopefully we're going to do one operation and then get the answer. That's all that one-step equations means. Just a couple of key ideas. This first one isn't really relevant to one-step equations, but I'm going to say it anyway just to get your mind thinking of it. Undo operations in reverse PEMDAS order. Some people may have seen this already, but we're going to start. PEMDAS, remember, is do what's inside the parentheses first, and then do the exponents, and then do multiplication and division, and then do addition and subtraction. Well, when you're solving an equation, you start from this side. So you undo the addition and subtraction by doing the opposite operation. Opposite of addition is subtraction. Opposite of subtraction is addition. So you do the undo of addition and subtraction. You undo multiplication and division. These are also opposites of each other. You undo exponents with square roots and kind of undo whatever's in the parentheses very last. So that's the first key idea. The second key idea is to get the variable, which will be the letter in this case. It can be any letter, X, Y, A, B, any letter. Get the variable to one side of the equal sign, so one side of the equation. I'll use those interchangeably. Equation or equal sign. And then the numbers, get those to the other side. So you can choose whichever side you want to move the variable to, but then move the numbers to the other side. That's all. All right, so let's look at a couple of examples. So over here, what I'm going to look at is I'm trying to get the variable all by itself, and I need to undo anything that's next to the variable. I only pay attention to numbers that are close to the variable on the same side of the equal sign. So the 97 is on one side, the x plus 52 is on the other side. I'm going to look at, so here's the variable. I want to get this to one side. Currently it's on the left side. So I want to get the numbers over to the other side. So I'm going to look at this 52. And I'm going to try and undo whatever this 52 is doing. It's a positive 52 because there's nothing in front. It's not a negative. It's a positive 52. So I'm going to undo that by subtracting 52. And I have to do that to both sides. So I'll subtract 52. I usually write a little arrow because it's kind of like I'm moving it over. 52 minus 52 is nothing. You could write a 0 plus x or just an x. And then I do 97 minus 52. And that is 45. Whoops. So there's my answer. All I'm doing is just leaving the variable on one side and moving the number over. And I do the opposite of what this number is, like what the sign of the number is. So this is a positive 52, so I subtract. If it was a negative 52 here, I would add 52 to both sides. And then you get your answer. So if you want to pause the video, you can try number 2, but I'm going to do it right now. So now I'm looking, the variable is on the other side. So I'm just going to leave it here. I'm going to try to get my numbers then. If the variable is on the right side, I'm going to get the number that's closest to it on the same side of the equal sign. I'm going to try to get this over to the other side. So what I can do is take this this negative 11 and do the opposite. Since now it's negative, or it's a minus, negative minus, I'm going to use those interchangeably. I'm going to do the opposite, which is plus 11, and then do that to both sides, plus 11, and it's an arrow going that way. So negative 11 plus 11 is 0, nothing, they cancel out, and I'm left with just p. Copy down the equal sign, and then negative 14 plus 11, they're opposite signs, so I have to subtract. So what is that, 14, that's 3, and the bigger number is a negative, so we got -3, and you can write p equals -3. So hopefully that's pretty simple. I was just undoing addition and then undoing subtraction. It was a positive 52 here, so that's why I did the minus. We'll worry if this is like a negative variable. We'll worry about that later. That's not a one-step equation. That's usually a two-step equation or multi-step. So did the opposite of this. It was positive. I subtracted to both sides. Opposite of -11 would be +11. I did that to both sides to get the answer. Yeah, deal with the numbers that are closest to the variable first. You're trying to move it away from the variable. You're trying to get the variable all by itself. Maybe that's another key idea. Get the variable all by itself. Let's look at a few more examples. Okay, on this first one, we have 9 times x equals 18. That's the same thing. You might see it written as 9x equals 18. Those mean exactly the same thing. And since it's 9 times x, and we want to get the variable by itself, we do the opposite of times. 9 times x, we're going to divide. So the opposite of multiplication is division. So we are going to divide by 9 to both sides. And that leaves us, those cancel out, and that leaves us with x equals, and then 18 divided by 9 is 2. So that's simple. If you plug back, I didn't mention this before, but if you plug the x equals 2 back into the original, that's how you check your answers. So if I plug in the 2 here, I would do 9 times 2. That comes out to 18. So it would be 18 equals 18. That's how you know you did it correctly. All right, the next one, simple one, same idea. It's -3 times x equals 27. So you do the opposite of times, which is divide, -3, -3. You're always looking at the numbers that are closest to the x. So that's why I'm dividing by 3. I'm not going to divide by 27 to both sides because that won't get the x by itself. The whole reason we divided both by -3, is because they cancel out on this side. So x equals 27 divided by -3, that's -9, I believe. And if you plug that back in to check your answer, -3 times a -9, that equals +27. So there we go. This next one, it's written sideways with this, but this is the same thing as a divided by 4 equals -11. And now I have division, so a divided by 4, if I want to get the variable all by itself, I have to do the opposite operation. So the opposite of division is multiplication, and that means I'm going to multiply both sides by 4. And I have a 4 on the top and a 4 on bottom. That cancels out just like I had like a -3 on top, -3 on bottom. That's the same idea there. So then we just get a equals, and then -11 times 4 is -44. We'll do one more example, and then that will be it. All right. Let's see. A rectangular pool, which is shown below, just a rectangle, has a length that is 2.5 times its width. What is the width of the pool? So I'm going to say this will be the length of the pool. This will be the width of the pool. The length is given to be 15 feet. So really what I'm going to do is I'm just going to read this again and try to write an equation using this little description. So it should be pretty simple. So a rectangular pool has a length, so I'm going to write down the length. The length that is, so is we can translate to an equal sign. So is translates to an equal sign. 2.5 times, that's 2.5 and then we could say times its width. So I would say times the width. So I've written an equation just based on this description. So the length is 2.5 times the width. And then I already know that the length, because it's given from the picture, is 15. So I'm going to say, all right, this is 15 feet. And it's going to equal 2.5 times, and I don't know the width. It's asking for the width. What is the width? So whatever it's asking for, whatever I don't know, I'm going to say that is going to be x. And then I have an equation that looks similar to what I had before, similar to that. So, yeah, now I try to get the variable all by itself. I have 2.5 times x. So to undo that operation, I divide. So I'm going to divide by 2.5. I don't divide by 15 because remember, I want these to cancel out. So it's always the number that's closest to the variable that you're dealing with. So divide both sides by 2.5, and then I get x on the right side, and then 15 divided by 2.5, you can do that in the calculator. I think that comes out to 6. So x equals 6, but in the context of this problem, if we're going to answer this question, what is the width of the pool, we could just say 6 feet because the units are feet. Oops. Sweet, and that's it. Have a good day. The problems that you're working on are similar to this. So there you go.